In this lesson, we're going to learn how to find dot products of vectors and also how to find angles between two vectors. So some background information before we get to some examples. The definition of a dot product of two vectors u and v is the notation u dot v and is equivalent to multiplying u1 times v1 and adding that to the product of u2, v2. So basically, we multiply the two x components, multiply the two y components, and we add together, and we'll have what we call as a dot product. Let's look at a couple of properties of the dot product before we get to finding dot products. So let's let u, v, and w, all lowercase letters bold, be vectors in the plane or in a space, and we're going to let c be a scalar. Sometimes k is a scalar, c is a scalar. Doesn't matter, however it's defined for us. All right, property 1 says we can take vector u and dot it with vector v, and that's the same thing as dot producting, if that's even a word, vector v times u. Property 2 says 0 times a vector in component form is equal to 0. Property 3 we can think of as the distributive property. So we're dotting vector u with the sum of vector v and w. So it just kind of follows algebra rules. We can decide to dot u and v, and then we can decide to dot u and w. And once we get those answers, add them together. Property 4 says when we dot product vector v with itself, we get the magnitude squared. 5 says if we have a scalar c and we're multiplying it by the dot product of vector u and vector v, we don't distribute c across a dot product like we do across a plus sign. So this is going to be equivalent to either taking that scalar, that number, and multiplying it into the u vector, and then once we get that answer, do the dot product with vector v. So notice c is not being multiplied by both u and v. It's either c times u vector u and then dot with v, or you can take vector u and dot it with c, that scalar multiplied by v. So we just choose which one we want to multiply the scalar by, either the vector u or v, but not both. All right, let's get to some examples. The directions are finding the dot product of u and v. So here we have u and v. So the notation is u dot v. And so what we do is we multiply the x component. So -4 times 5 is -20. Plus, as part of the formula up above. And the y components multiplied would be -4. So we get an answer of -24. So notice that the dot product of two vectors is actually, the answer is a number, or what we call a scalar. All right, so let's look at example 2. Vector u and v are both written in the linear combination form. So if you want to change those to component form, it'd just be 2, 6. And for vector v, -3, 7. So now let's do the dot product. Let's multiply the x components, -6, and add it to the product of the y components, 42. All right, adding those together, we get 36. So the dot product of vector u and v gives us a number, 36, also called a scalar. All right, let's do some more examples. All right, we're told to use vectors u, having these components, v is here, and vector w is here. To find the indicated quantity, state whether your answer is a vector or a scalar. All right, v dot w. Okay, let me pull down v, put it in front of me. Vector v dotted with vector w from above. Okay, the big dot here means dot product, so multiply the x's, multiply the y's, and add together. Negative 5 plus negative 12. My answer is negative 17. Okay, go back and read the directions. Are we supposed to do something else? Yeah. State whether negative 17 is a vector or a scalar. Well, it's a number, so it is a scalar. All right, let's look at example 4. We're asked to take 4 and multiply it by vector u. So thinking about vector u having components 2, 2, 4u would be 8, 8. We'll be dotting that with vector v, negative 5, 3. Let's multiply the x components for the dot product. Add 24. Final answer, negative 16. Well, that's not a vector, it's a number, so we call that a scalar. All right, example 5, I'll probably handle the parentheses first. So vector u, get that in front of me. I'm going to dot that with 2 times v. I'll go ahead and multiply 2 into vector v. So doubling those components gives negative 10, 6. And then once I'm done with dotting these two vectors, I've got to multiply it by vector w, or dot it with vector w, and vector w is what, 1, negative 4. All right, so let's handle this dot product first in the parentheses. So what's that going to give us? Negative 20 plus 12. All right, so that is not going to be a vector. That's just going to be a number. So I think I won't use those like inequality symbols. I'll just kind of put that in parentheses. And I still have vector w hanging over here. So this adds to negative 8. So I'm going to have a scalar times a vector, and that just means from the property that multiply negative 8 into each of these components. So I get negative 8, positive 32. And we can see we don't get a number as an answer, we do get a vector. Okay, so that's vectors and dot products. So now let's look at the back here. Now we're going to be asked to find the angle between two vectors. And so if theta is the angle between two non-zero vectors u and v, then we have the formula cosine of theta equals the dot product of the two vectors divided by the magnitudes of each of the vectors. And then, of course, for us to find theta, because that's our objective, if we want to find an angle theta between two vectors, the next step here would be to do the arc cosine on both sides of the equation. So theta would be equal to arc cosine, the second cosine key of that fraction, the dot product of u and v, divided by the magnitudes of each, the product of the magnitudes. So it gets a little tricky looking at all these straight lines here, but that really means times, those two numbers times, like this. Okay. All right, so the directions here for examples 6 and 7 are to find the angle theta between the vectors. All right, so it looks like I'm going to need some things. I'm going to need the dot product of u and v. So let me do that first. So what is that? Oh yeah, the x components multiplied, added to the product of the y components. So u dot v equals negative 8. So in my formula, I've got the numerator. So now let me find the magnitudes of each of the two vectors. And then I'll put it all together so that I can go to my calculator if need be to get theta. All right, so magnitude of u. Remember, the double absolute value bars mean square root. Go to each component of vector u, square them, add them together. That's going to be 16 plus 16. Remember, we have to add before we square root, so that's square root of 32. That does simplify. 16 times 2 is 32, so square root of 16 will come out as a 4. So Simplifying that radical, I'll get 4 radical 2. Okay, so let's find, I still need the magnitude of vector v. Magnitude means square root. Go to vector v, square each component, adding together, and square rooting. Well, it's going to be 4 and 0, so just 4. Square root of 4 is 2. All right, so we have everything we need now to assemble our formula to do an arc cosine. Okay, so I might just go straight to theta equals arc cosine. Maybe do a big fraction bar here. So in the numerator, the dot product is -8. And in the denominator, I have to multiply according to the formula, the two magnitudes. So 4 square root of 2 times 2 would give me 8 square root of 2. And you can go right to your calculator as long as you're in degree mode and do a second cosine of that fraction. Okay, and you'll get an answer. But I think we can do this without a calculator, because if I simplify this fraction, it's going to look like a familiar number that's on the unit circle, and I won't have to use my calculator. So the 8's divide into 1, so I'll have -1 over radical 2. And you may remember and recognize that if I were to rationalize this fraction by multiplying by square root of 2 over square root of 2, you're really going to get square root of 2 over 2. So if we think about our unit circle, where on the unit circle, oh, excuse me, I think there's a negative in here. Where on the unit circle is our x coordinate negative square root of 2 over 2, as long as we're in quadrants 1 or 2? Well, our x coordinate right here at 135 degrees, okay, is going to be negative square root of 2 over 2. So theta equals 135 degrees. And again, like I said, if you did it on your calculator and you're in degree mode and you were at this step, or even this step right here, you would get 135 degrees. So what we're going to do is we're going to verify 135 degrees by looking at a picture of these vectors. So going back to vector u, its components are 4, 4. So that means vector u, starting from the origin, goes in this direction. Plotting vector v, its components are -2, 0. So that would probably be about right here. So we're not coming off of the negative x-axis. So if I looked at the angle between these two vectors, it appears to be 135 degrees. All right, let's do another example of finding the angle between these two vectors. This time, let's start by graphing them and predicting what our answer is going to be. All right, we're in linear combination form. Now remember, when you look at this, we're missing the I component, so that really means we have 0i plus 4j, which in component form would just be 0, 4. So let's plot 0, 4. So 0, 4 would be here. This would be vector u. All right, vector v is missing the j component, so really we could write this as -9i plus 0j. The component form would be -9, 0, so that would be way over here at -9, 0. So I think my answer should be 90 degrees because that appears to be, since we're both vectors are landing on one of the axes, that appears to be a 90-degree angle right there. So I think my answer should be 90 once I do all the work. Okay, how do we get theta? Well, we access our formula. First thing, let's find the dot product. So that would be the x components multiplied. That would be 0 plus, well, when you multiply the y components, you also get 0. Okay, I mean, we might as well stop right here because we're getting 0 on top. We can go through and find the two magnitudes, but it's just not going to matter at the end. So the magnitude of u, square the 0, square the 4. That's 16. Square root of 16 is 4. Really, do we even need to do this when we can just count? Because we do have a vector that lands on one of the axes. All right, so what's the magnitude of vector v? Well, we could go through the same process, but why don't we just count it from the origin over to -9? Its magnitude would be 9. theta equals arc or inverse cosine of 0 over 4 times 9 or 36. So really that's just 0. So if we don't use the calculator to assist us, we're going to get 0. So we think about what angle on the unit circle has an x-coordinate of 0, and that would be up here at pi over 2, but in this case we're going to report our answer in degrees. We're going to get 90 degrees. And again, you can confirm that on the calculator by doing an arc cosine of 0. And that's it. We looked at dot products in this lesson, and we looked at how to find angles between two vectors.